Alright, Calculus, we are back like that. For sample test 1, numbers 10 through 18, let's jump right in. Okay, so number 10 here. It says, as we're looking at this, figure the graph shows the velocity. Okay, so that's a big idea there. The figure the graph shows the velocity. So this equals velocity. And velocity is kind of like what we would think of as first derivative a lot of times. Not like it has to be that way, but it's still kind of there. At which of the marked points is the speed the greatest? Okay, speed in this case is related to velocity. So speed is actually the absolute value of velocity. So when would speed be the greatest? Well, you look here, and this is like the highest velocity, v of t. But down here, this d is definitely further away than this b, which would make d the highest speed. Because even though it's the lowest number, numerically, like let's say this was, I don't know, 2, then this would be relatively down here like -5. Well, the absolute value of -5 is definitely greater than 2. Because 5 is greater than 2, so that's why it would be bigger. So the d is the speed. That was fast, super fast. That should have been like a 2-second problem. Probably spent too much time explaining that one. Alright, in the figure above, the area of these shaded regions. So we're talking about a shaded region. Look at this shaded region. It's the area between curves. Okay, no big deal. Easy to find. Area between curves, well, that's from left to right of the top minus the bottom. Okay, well, here's my left would be right here. So left equals 0. But what's the right? Where do we stop? What's this point right there? I don't know. Let's see what we do know. The top here, this is my top. That's going to be y equals 5. And the bottom is this piece here, x squared plus 1. Alright, that's not too bad. Well, what else are we looking at here? It looks like we can find where these two things intersect. Oh, that's a good idea. So when we look at the intersection, an intersect is when something equals something, and in this case it's the two functions. So that's going to say, when does 5 equal x squared plus 1? Okay, well if I subtract 1 from both sides, I get 4 equals x squared, and then square root, x equals plus or minus 2, which is true because it intersects both here and here, both places. So this would be 2, and this would be -2. I don't really care about the -2. I just want the 2. So we're looking for 2. So 2 equals my right. Alright, so what's my integral? It's going to go from 0 to 2. That's my left to right boundaries. The top is going to be the function 5. The bottom is that bottom function, that whole thing, x squared plus 1. Now I did something detail here. I put this in parentheses because this negative is going to apply to both of these terms. So it's going to be 5 minus x squared minus 1, if you were to think about it like that. So we can simplify that. 5 minus 1 becomes 4, so this is really the integral from 0 to 2 of 4 minus x squared dx. And then we do the antiderivative. That's 4x minus x cubed over 3 from 0 to 2. Notice that there's an x in each of these terms. So the 0 is kind of like irrelevance because you plug in 0, 4 times 0 is 0, 0 cubed is 0, so the 0 terms are going to go away. So I really just need to do 4 times 2 minus 2 cubed over 3. And then the other part is minus 0. So 4 times 2 is 8, 2 cubed is 8/3, over here for the next one. So that's really like 24/3 minus 8/3, which is, boom, 16/3. Done. Number 12. Ooh, this one's memorization. Hardcore memorization here. Alright, there's some crazy substitution you can go and do here, but in general, I see some telltale signs. First, this is what my eyes are wanting to see. It's thinking like a squared minus u squared, and up here is du. Well, in that case, u equals x, du equals 1 dx, and what else are we going here? A u squared equals x squared. Okay, with that in mind, I know that the antiderivative of this is something with arcsine in it, first of all. Arcsine. And I believe it's u over a. Yeah, u over a. Now the question is there anything over here like a 1 over a or something? And that's not true. That is true for tangent, but not for arcsine. So that takes this one out of it. And it eliminates that one. And arcsine of x, it's missing the over 2 part, the over a. So that one's out. And these two are not even close, which leaves us with a. That was easy. As long as you knew this. Memorize. Number 13. Ooh, this one's fun. Fun, fun, fun. Let's read. So we read and we see that it says points of inflection at x equals -1. So what does that mean? That means that f double prime either equals 0 or does not exist when x equals -1. In other words, f double prime of -1 equals 0. So all we really got to do is take second derivative, plug in -1, set it equal to 0, and then see what happens. Why do we need to do that? Okay, well, let's keep reading. The graph, point inflection -1. Oh, the value of k. Look, we have a constant k. So we got to do the derivative, double derivative, in fact. Well, let's prep it. First, I see that this would be 2x squared plus k x to the -1. So that's my f of x. If I take it further and then I go f prime of x, first derivative, that would give me 4x plus -1k x to the -2. Let's keep going. Okay, so f double prime of x is equal to 4. Drop that -2. It's going to be plus 2k x to the -3. So in other words, now we can plug it in. Alright, so we set that equal to 0, and we plug in 1. So it's going to be 4 plus 2k over 1 cubed, because x to the -3, oh, -1 cubed, pardon me. X to the -3 is really 1 over x cubed, and -1 to the -3 is really 1 over -1 cubed, which is really just -1. Okay, so we got 0 equals 4 plus 2k. Let's clean this up here a little bit. 4 plus 2k, but that's times -1, so it's really minus. Move the 2k over. We got 2k equals 4, k equals 2. Oh, that was easy. Well, this part was easy. This part, not so easy. But what did we really do? Keywords, point of inflection, x equals -1. That means this. Okay, next. Number 14. Oh, this is a piece of cake. There's two ways you can do this. Well, one, you can take the antiderivative of each, or the derivative of each one of these options and see which one gives you this. The other option is to realize that the antiderivative of sine of u du is negative cosine of u plus c, of course. So as long as we know that, we're good, we're golden. So let's apply it. We know then this would be u equals 3x plus 4, because that's the inside layer there. If I took the derivative with both sides with respect to x, du dx equals 3. Okay, now I don't have a 3 here, but I do have a dx, so let's work that around. So if I divide by 3, and then multiply by dx, and multiply by dx, what's that give me? Well, that gives me 1/3, and a du equals dx. So there's my dx, here's my dx. I'm going to take that out and replace it with a 1/3 du. Now I'm going to take this 3x plus 4 out and replace it with a u. and I need a 1/3. Okay, so that means we're going to have the integral 1/3 sine u du. Hey, wait, sine u du, that's negative cosine u plus c, and this constant 1/3 is just a tag along, so it becomes 1/3 negative cosine u plus c. Keep going. Negative 1/3 cosine 3x plus 4. Plus c, of course. Negative 1/3 cosine 3x plus 4. Hey, that was the first one. That was easy. Okay, so what's the big deal here? Why would somebody have chosen e? Well, they forgot the negative. That's why that's wrong. Cosine 3x plus 4, they forgot the 1/3, the constant. That's why that's wrong. C, well, they kind of had the constant, but you see this algebra we did here where we got 1/3 du instead of 3 dx. They forgot to kind of switch around the 3 there to get the 1/3, so that's why that's wrong. Here, they forgot the constant altogether. But they remember the negative, still forgot the constant, so that's wrong. A is your winner. Number 15. Keywords, buzzwords, right away I see it. Concave down. What's concave downward? Well, that means f double prime is less than 0, is negative. So I gotta, or in this case, not f double prime, y double prime, second derivative. Same deal. Okay, well, let's take this, modify it, and see if we can get to a second derivative from there. So y equals 2 times 4 minus x to the negative 1. Why would I do that? Because it's easy to take the derivative. I don't have to do a quotient junk rule here. So then y first power, not y first power, y first derivative. Okay, so we drop, chain rule, constant stays here. Chain rule, drop the negative 1. Leave the inside alone, but this is going to be negative 2 this time. So we got 4 minus x. Then we multiply by the derivative of that. Well, the derivative of negative 4 minus x is just negative 1. Let's simplify this. This is going to be negative 1 times negative 1. That's really positive 1. So we have 2 times 4 minus x to the negative 2. I could go ahead and rewrite that as 4 minus x squared into a denominator, but I'm going to take another derivative. So why do that? Y double prime equals 2 times negative 2 times 4 minus x to the negative 3. And then don't forget the negative 1, the chain from the inside. Alright, so we got negative 1 times negative 2, that's really positive 2, times another 2, that's 4. Okay, so we got 4 times 4 minus x to the negative 3 power. That's our y double prime. We want to figure out when is that concave down. Okay, when is that negative? Okay, well, let's do some stuff here now. We would have 4 over 4 minus x cubed. When is this negative? Negative how? Well, the top, the numerator, is always positive. So it's always positive down here. And the only way to make a fraction negative when the top is already positive is that the bottom would be negative. So I need to make the bottom negative. So when was 4 minus x quantity cubed, when is that less than 0? Well, let's cube root both sides first. That would give me 0 is greater than 4 minus x. If I move the x over to the other side, that would give me x is greater than 4. So there's my solution, and E is the answer. Just to test it, let's see what would happen. Let's say I plugged in the number 5. Okay, if I plug in the number 5, which is greater than 4, this should be negative. So I plug it in. And so if I plug this in right into there, that would give me 4 over 4 minus 5 cubed, which is really 4 over negative 1 cubed, which is really negative 4. Hey, it's negative. It's concave down. We got it. Next. Alright, what do we got here? Particle moves along the x-axis in such a way that its position at time t is given by x of t. What is the acceleration? Okay, so we have position x of t here. The question is, acceleration when t equals 0? In other words, what's a of 0? Well, I know that x prime of t equals velocity. First derivative equals velocity. The second derivative of position equals acceleration. So that's what I need to do. I got to take the derivative twice and then plug in 0. Let's do that. Well, it looks like we have a low-d-high rule, or a quotient rule here. So we have to do first derivative. Let's do it. X prime of t equals low-d-high. That's going to be 1 plus t times the derivative of the high, which is negative 1, minus high-d-low. The high is going to be 1 minus t times the derivative of the low, which is just 1. Okay, that wasn't too bad. And then down on the bottom we got 1 plus t quantity squared. Alright, let's simplify some things. Because up here, if I distribute this negative, that's minus 1 plus t. Over here, if I distribute this negative, that's minus 1 minus t. So it looks like the t's cancel each other out, and I'm going to have negative 2 over 1 plus t squared. Alright, well let's take this a little bit further. In other words, the first derivative, I could go even further with that, and that would be negative 2 times 1 plus t to the negative 2. That makes it a little bit easier to do another derivative again. Okay, let's do second derivative, which is really acceleration. Alright, so we have this negative 2 constant, it's a tag along. We're going to drop down the negative 2, so we got two negative 2's. Then we take 1 away from the power. The inside is 1 plus t. Well, 1 plus t stays, but then we multiply by the derivative of that, which is just 1. Alright, now I could, at this point, go ahead and simplify and then plug in 0. But why wait? Why not just plug in 0 now? Because let's see what I would get. This is 4 times 1 plus 0, which is really 1 to the negative 3 power, times 1. Well, 1 to any power, because 1 plus 0 is 1. 1 to any power is 1, times 1 is 1, times 4 is 4. The answer is E. Super easy. Next. Alright, what do we got here? For all real numbers x, f of x equals g of x plus 5. So what would we do with that? How would we work our way around? It looks like, oh, f of x is g of x plus 5. What are we doing? What's the area of the regions between f and g? We got options here. Oh, well, let's make a picture. Okay, so let's call this f. And that's 5 higher than G. No matter where we are. It's 5 higher there, it's 5 higher here. There we go. And let's say we wanted to find this area. Well, the area between two curves like this, between A and B, you could say, because of the interval AB, would be the integral from A to B of f of x minus g of x. Okay, now you're probably thinking, well, okay, yeah, that sounds good, but how do I take that further? Can I simplify that more? Yes, you can! Substitution. F of x is really g of x plus 5. So this would be like saying g of x plus 5. I'm going to make that substitution there. Now I'm going to subtract g of x. Aha! Now look at this. G of x minus g of x, gone. So it's really just the integral from a to b of the constant 5. D whatever. You could say dx, dt, who cares? Alright, so what would the antiderivative of 5 be? Well, it'd be 5x. We're going from a to b. It's top minus bottom. Well, yeah, we plug in b and then we plug in a. So it's going to be 5b minus 5a. But hey, look at that. We got an answer. It'd be C. Check done. That was easy. Number 18. I believe this is the last one for this little mini video. Alright, if y equals this, then what's the derivative? Oof. It's got a lot going on. Look at this. We have an a and a B, which means product rule. Well, let's figure out A prime. Well, A prime is pretty easy. That's really easy. A prime is just 1. What's B prime, though? If B equals natural log of x, but then squared on an outside layer, that's going to be a chain rule. So B prime, we're going to have 2 times that inside to the first power times the derivative of the inside. The inside is natural log of x. What's the derivative of that? Well, the derivative of natural log of x is 1 over x. Alright, so now y prime is going to be a b prime plus b a prime. Alright, a b prime. Well, a is x, and b prime is 2 natural log of x times 1 over x. Plus b a prime. Well, b is natural log of x quantity squared, and a prime is just 1. Alright, so I don't think it's this easy. Let's simplify just a little bit, see what we can get. Okay, so this 1 over x and this x, those cancel each other. Then we have 2 natural log of x plus natural log of x squared. So some people are looking at this, and I kind of see this as like 2l plus l squared. And that's not 3l squared. We can't combine it that way. But I could factor out this natural log of x. That would be like l times 2 plus l. Or if we were to bring that back, that's like natural log of x times 2 plus natural log of x. That looks like, is it this one, C? Yes, it is. There we go. That was too easy. Alright, so preview from the next one. In the next video, you're going to be seeing numbers 19 through 27. But for this one, we are done. See you soon.